Hello, my name is Prashant and I will be presenting my thesis, Fine Feature Reconstruction in Point Set Surfaces using Deep Learning. Deep neural networks have revolutionized machine learning, and applying deep learning to 3D geometry problems is an exciting new area of research. My thesis explores novel, data-driven approaches to reconstructing fine geometric features from 3D point clouds. It covers reconstructing sharp edges, as well as reconstructing fine features in general by the effective use of several deep learning models. First, I show that deep learning can be used to compute a scalar field representing the sharp edges of a surface, which I call a sharpness field. Computing the sharpness field for a point cloud allows us to identify the exact locations of sharp edges on the underlying surface, even if the point cloud does not contain points lying on sharp edges. This work also happens to be the first published machine learning approach to detecting sharp features in point clouds. My thesis covers different deep learning approaches to computing the sharpness field for a given point cloud. We start with convolutional neural networks and progressively discover more effective approaches using recently published neural network models such as harmonic networks, spatial transformer networks, and point net models. Now let's come to the applications of the sharpness field. We set out with the objective of reconstructing sharp edges. My thesis presents a new algorithm to accomplish this by modifying moving least squares approximation to incorporate the local sharpness field. This preserves sharp edges while still removing noise, giving us edges that appear to be chiseled out of stone. My thesis also presents an algorithm for segmenting a point cloud into patches using the sharpness field, as well as an algorithm for extracting an explicit graph of the sharp edges represented by the field. My thesis also presents a novel and computationally efficient method for reconstructing fine features in general from point clouds by applying domain translation. We know that in the field of deep learning, generative adversarial networks, or GANs, have been used to translate images between two domains, such as street maps and satellite images. We can improve the quality of surface reconstruction from point clouds by training a conditional GAN to translate between local neighborhoods of point clouds and local neighborhoods of triangular meshes. By utilizing the translated neighborhoods, we see significant improvement in the reconstructed surfaces. Many fine details are recovered. Here is the list of the published papers of my PhD work. I invite you to check out the papers as well as my thesis for all the details. Thank you.